Alright, hello class. Today we're going to be talking about the properties of logarithms. It's going to be our 21st lesson. And this one should be pretty straightforward, but there's a lot of practice problems for you to do in this homework. But let's get to the properties, and let's look at examples on how to use them. Okay, so here's our main properties that we're going to be looking at. We talked about some of them last time, but we're going to talk about the remaining ones here. And then, again, talk about how we use them. So the first one is this sum rule, okay, or it's often called the product rule, because what we have is, if I have the log base b, and it works for any base, of two things multiplied together, we can split that up using addition. So log base b of a times b, capital A times b, I could split up with addition here and make it log of a plus log of b. Okay, and we have a similar thing for division. If I divide two things, this is often called the quotient rule or the quotient property. Maybe I should use property instead of rule there. There we go, got it rewritten as property now. So if I have the log of two things dividing, I could split it up with subtraction instead of addition. Okay, so the log of a over b would end up being log of a minus log of b. And then this one, it kind of smudged a little bit. Let me see if I can make that look a little better. And the log of a to a power, we could call this the power property or the power rule. Okay, tells us that if I have a to some power, what we can do is bring that power outside as multiplication. So I have the power times log of a. Right? So this one's extremely important, this bringing the power outside. Okay? So these are the first three we're going to talk about, and they're very, especially this last one, is very helpful for when we try and solve equations and when we look at applications. So at the moment, I think it might be kind of difficult to see why we might use these, why we would even bother with these properties, but maybe you'll start to kind of get an idea of what this allows us to do is actually simplify what we have. Okay, depending on what we need. All right, so let's just look at an example. Okay, let's say we had log base 2 of 4x. And I wanted to simplify this. So what I have here, this is a product, right? I have two things multiplied together. Right, I could fit a dot in there, 4 times x. And so we can split this up as log base 2 of 4, and since we're multiplying, I split it up with addition. So it'll be log base 2 of 4 plus log base 2 of x. Okay, now from here, log base 2 of 4, remember this asks, I'll do it up here in a different color, this asks our base to what power is equal to 4. So this whole thing here comes out to be 2, since 2 squared is equal to 4. So what this ends up being is 2 plus log base 2 of x. Okay, so we've actually simplified this down. I think, depending on what you're doing, 2 plus log base 2 of x is probably nicer than log base 2 of 4x. Okay. All right, let's look at one that uses division. Okay, let's say we have log of y over 1,000. Okay, so if we remember, a log all by itself without the base written is actually base 10. Okay, so since we're dividing, I can actually split this up, okay, as log of the top minus log of the bottom. And we can actually evaluate this. Log of y would have to stay log of y, But log of the denominator, well, that we can write as 3, right? Because this asks, once again, I'll do it over here, 10 to what power is 1,000? And that answer is 3. So this comes out to be 3. Okay, so we end up with log of y minus 3 when we simplify. Okay, so there's the product rule, the quotient rule. Let's look at the power property. Okay, let's say I have log base 3 of 4 raised to the 10th. Okay, so with the power, if I have something to a power inside here, I can move that outside as multiplication and get 10 times log base 3 of 4 and rewrite it using multiplication. Okay, and that's basically that. I can't really break this down any further, unfortunately, but yeah, there we go. We use the power rule. Okay, let's look at some examples that kind of mix these, complicate them a little bit, that, you know, that go a little further. Okay, let's say I have log all of 100x squared over z cubed. All right, for this one, it's going to mix a lot of our rules together. Okay, so what we're going to do, and what this would actually, how this would be given to you, it's tell you to expand this. So expand and simplify. Okay, so remember log without the base is base 10, so we'll use that in a little bit. So what we're going to start with is the division, the fact that we are dividing. So I don't want to start with powers, I don't want to start with 100 and base 10 acting well together. I don't really want to start with the multiplication up here. I want to start, and we usually always start with the divisions. So this is going to be log of the top minus log of the bottom. Okay, so log of the top minus log of the bottom. And that's usually where I always start, unless the entire thing is being raised to a power. Then I might do something else first. Okay. Now in this one, I now have a product. I have two things multiplied together. Okay. So I'll break that up using addition. So this one can now be broken up as log of 100 plus log of x squared. Okay. And I'll leave this alone for right now. I'll just say that that's minus log of z cubed. Okay, and now I have one more step. Log of 100, that we can actually figure out over here. If I do it up here, this is asking 10 to what power is 100, and that answer is 2. So this guy comes out to be 2. Okay. For these two, we have our input raised to a power. Okay. So we're going to take these powers and bring them outside. Okay. So I'll have 2 plus 2 log of x. Let's put z in there. Of x. And it's still a minus 3 log of z. All right, and there we go. We have expanded and simplified this as far as we possibly can. Okay, so let's look at another example. Okay, let's look at this one. We have the natural log. If you can see that. This one, maybe I didn't write it as well as I could have. This is the natural log of 36 square root of x all over y e times e to the fifth. Okay? So I'm going to start, I always, and this isn't the only way to do this, but I think it's the nicest way to do it, is to split up the fraction first. Get rid of the fraction. You always want to get rid of the fraction first. And that'll be the log of the top minus the log of the bottom. Just make sure you keep the base right. So I have natural log of the top minus the natural log of the bottom. Okay? Fair enough? All right, now from here, what I'm going to do is, for each of these, we're going to split them up. Since now it's 36 times a thing, and here's y times a thing, we can split these up using our addition rules. Okay? Or our product rules is what I should call them. Okay, so I'll call this, I'll say product. And we split these up with sums. Now you have to be careful here, because that minus is going to affect the whole thing. So what I'm going to do is say this is the natural log of 36 plus the natural log of the square root of x. Okay, now this will be minus, and I'm going to put brackets because it's going to be minus the entire thing, but it will be minus natural log of y plus natural log of e to the fifth. Okay, so if we'll focus, we can see where we're at now. All right, now there's a little more work we can do in some of these things. We are not quite done yet. This ln y is as simple as it will get, but this ln e to the 5, remember, the natural log and the e will cancel each other out. So if I have the base and this matching, it will cancel out. Or I can just think, you can think of it like this. I can move the 5 down, it's multiplication, and then I have the natural log of e to the 1, or a natural log of e, that's going to give us 1. Okay, so we could do it like this. 36, remember, is 6 squared. So we can actually simplify this a step further if we want smaller numbers to deal with. Now here's the important part, or one of the important things. The square root, if you remember, is x to the 1/2 power. Okay, so we have a couple powers that we can bring out in our next step. Okay, so I'll go ahead and also distribute this negative across so that I get minus natural log of y, then minus, I'm going to go ahead and bring that 5 out too, 5 ln e. Okay, so we get here 6, nope, sorry, not 6 on the outside. We get, oh, again, we get the 2, we bring the 2 outside, so I get 2 ln 6. Here I get plus 1/2 ln x. Here I get minus ln y, and here I get minus 5. And there we go. We've now taken this expression here and expanded it out to this expression here. Okay, let's do one more expanding problem, and then we'll look at compressing problems, which kind of go in the opposite direction, but they utilize the same stuff. Okay, so here, whenever you see the entire thing in a square root, like we have here, we actually could apply it to part of it. So let me do that. This, I could say, is log base 2 of the square root of the top over the square root of the bottom, which will just be 4, since 4 times 4 is 16. Okay? So let me put parentheses around here so it's not ambiguous as to what's inside the log. So now I have log base 2 of the square root of some stuff all over 4. And so now we can use our quotient property. So I can say that this is log base 2 of the top minus log base 2 of the bottom. I think we've seen this one enough times now that log base 2 of 4 is 2, because 2 to what power is 4? 2. Okay. This one though, this whole thing is being square rooted. So remember last time that square root came out as a 1/2, and that's actually one of the nice things about these log properties, so let me do it here, is that we can get rid of square roots. Right? So this will be 8x cubed, the whole thing to the 1/2. And I can actually take that square root away and make it multiplied by 1/2. Right? And as we said in the last step, this is 2. Okay, so what's happened is I've actually taken that square root that we had here, square root of that stuff, and just brought it out as a 1/2. So we could actually skip this intermediate step once we get more familiar with it. But yes, square roots can leave the log and become just multiplying by 1/2. And I don't know about you, but I would rather multiply something by 1/2 than try and take the square root of it, depending on what it is. Okay. Now we can use our product rule here. Right? We have a product 8 times x cubed. We also have x to the 3rd power. This is technically to a 3rd power as well. But let's go ahead and expand that out. Now, I'm going to leave that 1/2 there, so be careful there. I'll put this in brackets. This will be 1/2 times log base 2 of 8 plus log base 2 of x cubed. And this entire thing minus 2 still. Okay. Now here, log base 2 of 8, I'm basically asking 2 to what power is 8? And of course that would be 3. So this thing comes out to be 3. Alright, so we get still 1/2 on the outside, and I get 3 plus, now I have this x cubed, so I can take that 3 out and make it multiplication. Okay, so I have 1/2 times 3 plus 3 times log base 2 of x, and this whole thing minus 2. Okay, now all we'll do, distribute this 1/2, do our final simplification, and we'll be done. So this will be 3/2 plus 3/2 log base 2 of x minus 2. Okay. Now 3/2 minus 2, 2 we can rewrite as a fraction as 4/2, right? So this is technically 4/2. So we're taking 3/2 and subtracting 4/2. So what we end up with is 3/2 log base 2 of x minus 1/2. And there we go. We've simplified this monstrosity that we started with down to here. Now, what I want to mention is you don't have to write every single one of these steps. I mean, when you start to get familiar with this, you start to get an idea of, oh, the 1/2 comes out, the things break up, the powers come outside, and then we just simplify everything. Okay, so let me show you now an example of where we go in reverse, where we take things from a big expression and sort of reverse them back. Okay, so here's kind of how it will be told us. So tell you to write the expression as a single logarithm. So what it means is we're started with this expanded thing and we want to bring it back in to be a single can do. Since I have two logs subtracted, this is our quotient rule backwards. So remember, it's always the top minus the bottom, right? So it was always top minus the bottom. And with our logs, of course. So we can redo it as now log base 5, always keep your base, of top 15 divided by the bottom, which is 3. So now I have log base 5 of 15 thirds. Well, 15 goes, or I should say the other way around, 3 goes into 15 nicely. We're going to get 5. Oh, log base 5 of 5, that's 1. Alright, so knowing this property, knowing how to do it in reverse can actually really help help you simplify, because we started with this nasty thing and guess what? It just turns out to be 1. So there you go. You get your answer is 1. Alright, let's look at another one. Okay, so here's an example. Say we have log of 25 plus log of 4. Well, if I want to compress this into a single log, so if I want to compress, okay, remember with a plus that becomes multiplication. So I'll get log of 25 times 4. Okay, which, you know, going the other way now is log of 100. And log without a base written is always base 10, so this is asking 10 to what power is 100. Again, I think we've seen that enough times now to know that this comes out to just be 2. Alright, and there we go. So both these that we just looked at actually came out to be nice numbers when we compressed them back down into a single log. Let's look at one that won't be, say, as nice, but we can still do it, and we can reduce it back. So we're just going in the opposite direction. Okay, so here is an expression. We have 1/2 log base 2 of 9 minus 3 log base 2 of z. So we're going to compress this back together into a single term to see what we get. Okay, so we kind of go in the opposite order. We're going to start with powers in this case. So we're going to start with powers, which tended to be our last thing last time. So for every constant I have on the outside, okay, I'm going to move inside of the log. Okay, so if I have 1/2 times log base 2 of 9, I will then get log base 2 of 9 to the 1/2. Okay, then here, I'm going to take this 3 and move it up as this is log base 2 of z cubed. Okay, so 3 log base 2 of z becomes log base 2 of z cubed. Alright, some of you have seen this already. Log, or actually I'm just looking on the inside here, 9 to the 1/2, that's the square root of 9. That's just going to be 3. So we just get log base 2 of 3 here, minus log base 2 of z cubed. Okay. Now we can bring these together as a single logarithm, because when I have these subtracted, we can use our quotient property. And the quotient property says if I have two logs, and remember they got to be the same base, and they're split up with subtraction, we can take this and make it division, because it's always log of the top minus log of the bottom. So it'll be log base 2 of the top, which is 3, over the bottom, which is z cubed, and there we go. We have now started with this expression and reduced it down to a single logarithm. Where this comes in handy is actually when you're solving equations or looking at applications, because what happens is you say start with some, or when you set things up you get this big expression in logs, and reducing it down makes it so much easier to solve. Okay. Let's look at another example. Okay, so this one is kind of involved. I've got a lot of pieces going on here. But we're going to start with the powers. Okay, so I'll write that over here just so I keep it track. We're going to start with the powers. So all the constants on the outside. So this 3 log 5, I'm going to bring that in. All right, this 1/2 log x, I'm going to bring that up. This 7, I'm going to bring up. This 3, I'm going to bring up, and make every number on the outside, bring it into the logarithm and make it an exponent. Okay, so this will be log of 5 cubed. This will be log of x to the 1/2 power. This will be minus log of y to the 7th, and this will be plus log z cubed. Okay. Now, keep in mind, remember, we have the same base here because we're always using base 10. Okay? Alright, so now 5 cubed, remember we're trying to bring this in to be a single log. So 5 cubed is 125, so this will be log of 125. This I could rewrite as log of square root of x, or you could leave it as x to the 1/2. Read your directions very carefully on MyLabs Plus and see what it says, because it may actually tell you to write things as roots, like to write things as square roots or cubed roots, or it might say to just leave it as x to some power. Okay, so just read your directions very carefully there. I'm going to go ahead and put it as a square root. Okay. And then these two don't really simplify much. Okay. Here, there are a lot of ways to proceed from this point. One of the best ways, I think, is just start going from left to right. Okay? Start here and say, oh, since I have a plus, this is a product property. So this will join into log of this one times this one. So it'll be log of 125 times the square root of x. Okay? And we do that, and we just ignore this stuff for a minute. Okay? So just go left to right and do it a step at a time while you're still learning this. Once you get a hang of it, you'll start to kind of see what happens. Okay, you'll kind of start to understand what's going on. Okay, but now this, I have a minus, right? So now I'm going to use my quotient property, which says that if I have a minus, it's going to be log. Make sure y'all can see this. It'll be log of the top over the bottom. So I didn't prepare for that as well as I should have. Let me rewrite this a little bit. Okay, so it's log of the top, which is 125 times the square root of x, over y to the 7th. Top, bottom. Okay, and I still have this plus log of z cubed. Okay, and now I just do this final step. I have a log of some stuff plus log of some other stuff, so this will just be a product. Okay, so I will do that off to the side here. It will be log of 125 square root x all over y to the 7th and times z cubed. And since I'm multiplying this fraction here, I could actually bring that z cubed up because this is z cubed over 1, so I could actually say that this is log of 125 square root x z cubed all over y to the 7th. Okay? And there we go. There we have it as a single log. Now, the reason I did this is because if we go back to our original, and actually we could even start here. Every positive log, those inputs end up on the top, right? We have 125, we have the square root of x, we have plus log z cubed. All those ended up on the top. Every every negative log, say y to the 7th, ended up on the bottom. Okay? And you'll see this in the other examples where we went in the other direction. Let me pull one up here. Here, I had 100, z squared, z cubed, or x squared, z cubed. The 100 and x squared had pluses, the z cubed had a minus. Okay? Here, when it was all said and done, my 36 and square root of x, they had pluses. My y and e to the 5th had minuses. Minus, minus. So each piece, even though we simplified it further, each piece that had a minus was in the denominator. Each piece that had a plus was in the numerator. Okay, so that is the pattern that you will actually see every time you do this. Right? The stuff on the numerator comes out to have plus logs. Stuff on the denominator comes out to have minus logs. Alright. Again, you will start to kind of get a handle of that pattern the more you do these. Right? They just kind of take practice. Right? The more you do it, the more you kind of start to see how they link. And like I said, this is way more steps than I would normally actually do myself. Because eventually you kind of start to get a handle of how these things break up or how they compress back together. Remember, positives go on top, negatives go on the bottom, and the numbers on the outside end up being your, your exponents. Okay. So most of this lesson is all about just expanding logs, compressing logs, simplifying logs, using all these properties. But the last thing we're going to look at, this last property, and this is actually an important one, comes from how do we evaluate more complicated logs. Okay, so for example, like let's say I had log base 3 of 17. And I wanted to figure out what that was. Well, this is asking the question, right? 3 to what power is equal to 17? And here's the problem. I don't know. Right? I don't know. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. 3 cubed is 27. So, some number between 2 and 3? It wouldn't be equal to either because that would either give me 9 or 27. But, right, that value I'm looking for is probably between 2 and 3 somewhere. But the question is, where? And how do we find values like this? Especially considering, when we look at our calculator, I have an older one here, but I have a log button and I have an ln button, but I don't have a log base 3. Alright, camera messed up. I'm not really sure what happened there. But what I was saying, most calculators, no calculator that I know of, unless it's a really, really expensive one, has a log base 3 button or a log base 2. Why? Well, because it would take way too many buttons, right? We can have any base. So then the question becomes, how do we find values like this? Right? right? And it comes from this final property that we're going to look at, which is this, that log base b of any base of any value, say capital A, is the same as log of A over log of B, using our normal base 10. Or it's the same as natural log of A over natural log of B. Oops. Not capital B, lowercase b. Okay. So what this allows us to do is allows us to use a calculator to help us find this, because log base 3 of 17 using this property, and this is called the change of base property. Okay, because what we're doing is we're changing the base to use base 10 or base E. By the change of base property, log base 3 of 17 would be log of 17 over log of 3. Okay, or we could use natural log. Natural log of 17 over natural log of 3. Okay, so let's see what that is. If I do log, I'm not sure we can see that very well. There we go. If I do log of 17 divided by log of 3, we get 2.5789. Okay. Let's try it with natural log. Okay, natural log of 17 divided by natural log of 3. Check that out. It's the same thing. So it turns out that the answer is about 2.5789. So if I raise 3 to this, 2.5789, and notice, like, it just keeps on going. It's not a nice number, right? It never settles down. But if I did 3 to the answer, right, if you hit second minus sign, that's answer, that uses the same value you had here, you get 17. If I try 3 to the 2.5789, I get 16 point a bunch of 9s repeated. Okay. Oops. And then if I do 3 to the 2.5789, everything I see there is 0, 1, 9, 2, 3, we get 17. So that's close enough to get it to round to 17. Let's see if this actually works on ones we know, right? If this is actually true, that means log base, let's say 5 of 25, which we know is 2. Okay, we know that this should equal log of 25 over log of 5. Let's try it. Let's do log 25 over log 5. And we got 2. Look at that. ln of 25 over ln of 5. 2. Okay, how about, we know, let's do another one. Log base 3 of 1 over 27. Right, this 1 over 27, that's log base 3 of 1 over 3 cubed. So that's log base 3 of 3 to the negative 3. So this should come out to be negative 3. Let's see. Log. Okay, so it's the value 1 over 27 divided by log of the base 3. And look at that, negative 3. Now, you don't need that for these values, right? But it's very helpful if you need to find something like log base, let's say 7, log base 7 of 33. Right, so 7 raised to what is equal to 33? I I don't know off the top of my head, but I could just do log of 33 divided by log of 7. So I actually write it out. Log base 7 of 33 is log of 33 over log of 7. Plug that in. We get about 1.7968. Okay, if I want to check, 7 to that power is 33. And there we go. That's it. So that's really all all there is to talk about in this section. I think this last property is very helpful when it comes to finding these values and checking your work. Okay. And as always, let me know if you have any questions.